Okay, so this is going to be our 7.7, 7.5, and 7.6 review with multiplying and dividing radicals. So objectives, we're going to look at the FOIL, distributive property, area model, being able to multiply like that. And then also a process which is called rationalizing the denominator. So it's actually really important that you know this word because this is actually referred to on test, homework, and things like that. So make sure you realize or pay attention to any time this video brings up rationalizing or just rationalizing the denominator, which basically is the process of multiplying to remove the radical from the denominator. And this is, because there's a denominator involved, this is what is necessary for dividing. So we actually don't divide, we rationalize the denominator. Alright, so first here are examples of multiplying. You can see that we have binomials that we're multiplying. So in this case we use either FOIL or the distributive property or the area model. We all know that I'm a little partial to the area model, so we're going to set that up. It's not the square root of 3, my bad. Negative square root 3, square roots of 10. And then we've got the square root of 3 and 2 square roots of 10. Okay, so basically what happens here is the numbers outside of the radical are multiplied and the radicands are multiplied. So when we multiply for this section, we get 2 square roots of 9, which is equal to 2 times 3. So this answer right here is 6. So that's the first thing that we're having. That's going to be our first number. Okay, then we go ahead and we multiply for the next section. So we have negative 3 square roots of 30. Okay, so we want to think about, can we break 30 down into some squared numbers? So we got 6 and 5, 2 and 3. So the square root of 30 does not break down. So this is going to stay negative 3 square roots of 30. Then we're going to multiply for the bottom left corner. So we have 2 times 2, which gives us 4. And then our radicands multiply to 30. Again, that's not going to simplify, so it's 4 square roots of 30. So far we have minus 3 square roots of 30 plus 4 square roots of 30. And then finally multiply the bottom right corner. So we have negative 3 times 2, which gives us negative 6, times the square root of 100. That simplifies to negative 6 times 10, which is going to give us the answer of negative 60. Okay, so now again we look at being able to do this with like terms. So we have non-radicals that we can combine, and that's going to give us negative 54. And then we have these radicals that we can combine because again they have the same index number, so they're both square roots, and they have the same radical, or radicand, sorry. So those are the ones that we can combine, and when we combine those, we have negative 3 plus 4, which gives us plus 1 square root of 30. And so that would be our final answer when multiplying. Alright, so again, we can do the same thing with this problem right here. We have x square roots of y, and then y. And then we have 3x square roots of y and negative 2y. Alright, so we multiply these, we get 3x squared square root of y squared, which is then going to simplify to 3x squared y. And then on this one, the y doesn't have a radical, so we're going to just have 3xy on the outside and the square root of y. And that one doesn't simplify, so again we have 3xy square root of y. Then we multiply here, again no radicals, so we've got a negative 2xy square root of y. Really the order doesn't matter, it's just in math we typically write things in alphabetical order. And again, this one doesn't simplify because that square root or that radical is not going to simplify. So it's going to stay that right there. And then we have negative 2 and y times y, which gives us y squared. So this one also doesn't simplify. So we have negative 2y squared. Okay, so as you look at this, you can see that we only have two like terms, these right here, that are diagonal from each other. So that means we're still going to have 3x squared y minus 2y squared, and then we can combine our two radicals, so we have 3xy. Remember, in order for this to work, the value or the exponents outside of the radical also have to be the same. So we have 3 and we're taking away 2, which gives us the answer of 1xy square root of y. And so that would be our final answer on that one. Okay, so here are ones for you to be able to try. So pause the video at this point and then you can check your answer with what I write down after you're done doing it. So again, pause your video here. Alright, so here are your answers. For the first one, it is -8 plus the 2 square roots of 3. And then for the second one, it is x cubed y squared plus x cubed y square root of y minus xy square root of xy minus xy square root of x. So again, these radicands weren't the same, so we couldn't combine those to be able to simplify this one. Alright, so something different. In this case, we aren't doing a binomial times a binomial. This is actually a monomial, one term right here in both of these. For the first one, we're multiplying the monomial into the binomial, so this is the distributive property. And then here, we're just multiplying, so this is really just multiplying terms outside and inside of the radical together. So when we do the distributive property, we end up having 5 times 2, which gives us 10, times the square root of 5 squared. Then we have, again, 5 times 2, but it's minus, so 10, and then the square root of 5. We know this is going to simplify, so we've got 10 times 5, or, sorry, not 25, 50, minus 10 square roots of 5, and so that's our final answer right there. On this one, we multiply the 4x and the 2x, and we get 8x squared. And then the square root of 27 times 3 is 81. And then we can simplify because this is 9. So we're doing 8 times 9, which is 72x squared. And so that's our final answer for this problem. Okay, so again, here are problems. Pause here and then double check your work with what will pop up. So again, pause at this moment. So on the first problem, it was pretty easy. Same thing that we've done, 40x minus 12 square root of 5x. Now on this other one, we had this cube in here. So when we multiply that by x, we end up getting x to the 4th right here. And so then we have the square root of x to the 4th, which simplifies to x squared. So 3x squared is our answer for this last problem. So again, sometimes if there's exponents inside with the radical, or sorry, the radicand, make sure that you're using the product property of exponents and then simplifying. Okay, so dividing, it's actually considered improper to have a radical in the denominator of a fraction. It's just not mathematically appropriate. Therefore, we do a process called rationalizing the denominator to remove all radicals and make the denominator a rational number. So, one of the big things behind rationalizing a denominator is if there is a radical binomial, we use conjugates. So remember, we've talked about conjugates before because these were the factors of the difference of squares. And if you remember, we looked at these are where they have the same numbers, but one is being added and the other is being subtracted. So in the case of this problem right here, this first one, we have subtraction going on. So that is our first factor, and we want to multiply by the one where it's going to be added. So we're going to do 3 plus the square root of 2. And what you do to the denominator of a fraction, you also have to do to the numerator. Okay, so if we go and just show, for example, of why this relates to the difference of squares, eventually we're going to shortcut this. We've got 3 times the negative, or 3 in the negative square root of 2, and then we have 3 in the positive square root of 2. So when we fill this in, we have 9, we have minus 3 square roots of 2, we have positive 3 square roots of 2, and then we have negative square root of 4, which is equal to negative 2. So what happens is these two, again, remember, there are the middle terms, and they cancel each other out. And so what we're left with is this number and this number, which we can combine, and there's going to be no more radical in the denominator. So 9 plus negative 2 gives us 7, and then we just distribute here, and so we get 12 plus 4 square roots of 2. And then that's our answer for dividing, in that it's been rationalized, because again, there is no radical in the denominator. And we did that by multiplying by conjugates here. Remember, it's the negative and the plus, and then the same numbers that make it a conjugate. So on this next one, what we know is that we are going to, I didn't mean to put an equal sign there. We're going to multiply by the conjugate of the denominator. So if this is the square root of 5 plus the square root of 6, we're going to do the square root of 5 minus the square root of 6. And so then when we multiply this out, we know that for the denominator, what's going to happen is, since it's supposed to be a difference of squares, it's going to be the square root of 5 squared minus the square root of 6 squared. So the first term squared minus the second term squared, which is going to simplify to 5 minus 6, which is going to give us negative 1 in the denominator. So now on the numerator, we can set this up here. 2 square roots of 3 minus the square root of 5. And then the square root of 5 minus the 5 minus the square root of 6. Multiply these, we get 2 square roots of 15 minus the square root of 5 squared minus 2 square roots of 18, and also plus the square root of 30. So we know the square root of 30 isn't going to simplify. So we have the negative square root of 5 squared, which is going to give us negative 5. We know that 18 can be simplified to negative 2 times the square root of 9 times the square root of 2. So this would be minus 6 square roots of 2. Then we have plus 2 square roots of 15 and the square root of 30. So none of those are going to combine. So our final answer is, we've got negative 5 minus 6 square roots of 2 plus 2 square roots of 15 and plus the square root of 30. And because we are dividing by negative 1, that allows us to actually change all of the signs. And so our final answer can be, with all of this, can be written as positive 5 plus 6 square roots of 2 plus 2 square roots of 15 plus the square root of 30. And again, that only worked because after we rationalized the denominator, we had a negative 1. So that isn't always going to happen. Alright, so again, here's a moment for you to be able to pause the video and double check your work. So go ahead and pause now. Alright, so here are the answers for these two problems. So the first one is 2 plus 2 square roots of 15 minus 4 square roots of 3 minus square root of 5. The order does not matter because of the commutative property of addition. It's just usually when we write this, we do want our whole number out front, just like how we want our highest variable with the highest degree out front. Okay, for the second problem, we have 6 square roots of 7 minus 6 square roots of 8, because after we rationalized the denominator, we ended up with a negative 1, so we could change the signs. Okay, so in this case, we do not have binomials. So monomials actually do not have conjugates. So we really don't multiply by the conjugate. We just multiply to try to get rid of the radical. So a lot of times when we do this, we want to be able to simplify the radical. So in the case of 32, we want to think of it as breaking it down. So 32 is 16 and 2. So this is the square root of 16 times the square root of 2. So really what we have is 4 times 4 square roots of 2. So we're going to rewrite this, and instead we still have 6 square roots of 2 minus 1. But now this is 16 square roots of 2. And the part that we have to rationalize here is the square root of 2. Well, the easiest way to be able to rationalize a square root is to be able to multiply it by itself. So what we're going to do is we're going to multiply the denominator by the square root of 2, which will then give us 16 times the square root of 2 squared, and that these will end up canceling each other out, which is what we want. And then what we do to the denominator, we have to do to the numerator. So we're going to multiply this in, and so we have 6 times the square root of 2 squared minus the square root of 2. And so then all of this simplifies, because again this is going to cancel each other out. And we've got 12 minus the square root of 2. And then we got 16 times 2 in the denominator, which is going to give us 32. And so that's our final answer on that one. Now on this problem, we have x to the 5th. So again, we want to factor this out or rewrite it. So remember, in this case, we divide by the index number. So we've got 5, and then 2 goes into 5 2 times. So we have x squared with a remainder of 1. So that's what this denominator simplifies to. So then again, x cubed we can write as 5x times the square root of x plus 4 over 5x squared square root of x. It's the square root of x that we have to rationalize, so that's what we're going to be multiplying by. So square root of x over the square root of x. So we go ahead and multiply this in here. We end up getting 5x squared times the square root of x squared, or so times x. And then we multiply it here, and we get 5x times the square root of x squared, or x, plus 4 square roots of x. So then this simplifies because we can use our product rule here. We have 5x squared plus 4 square roots of x over 5x cubed, and so that's our final answer there. Alright, so again, here are problems for you to be able to work on and see if you can simplify. So pause your video now and check your answer later. Alright, so here's this video right here. So both of these would be acceptable answers for the first one. Notice that I simplified 4 square roots of 24 to 8 square roots of 6 and multiplied both the numerator and denominator by the square root of 6. Then this would be our answer for the second one. So notice I simplified the square root of the square root of x cubed y cubed to be 3xy square root of xy. Okay, one last thing that I want to talk about is that if we have a denominator that isn't a square root, so let's say we're just going to do 3x plus y over 4 cube root of x squared y. Okay, so what we need to think about here is we need this value right here. We need both of these to end up being x cubed y cubed, so that we can get rid of that cube root. So that what we'll have is the cube root of x cubed y cubed, and so those will cancel out. So when you think about that, to be able to get x cubed, we need to multiply by x, and to get y cubed, we need to multiply by y squared. So what we're multiplying by here is still the cube root because it's got to be inside of that radical. But now we're going to do xy squared, xy squared. So when we multiply this in, we're going to have 4 times the cube root of x cubed y cubed, which is what we wanted. And we'll simplify to 4xy because the cubes will cancel each other out in the cube root. And then here what we have is 3x cube root of x y squared plus y times the cube root of, I'm running out of space. So our final answer would be 3x cube root of xy squared plus y cube root of xy squared. And again, those aren't like terms because the first term has an x and the second term has a y. So that's as simplified as we can get. Alright, so this is the video for our multiplying and dividing, and hopefully it helps you in being able to do your work and having questions to ask during our class time.